This is a continuation of the post-lab discussion for activity number 7 entitled Types of Chemical Reaction. So this is now part C, where we carried out single replacement reactions. There were 3 setups. The first involved copper sulfate and iron. So this is the copper sulfate solution in a test tube. Into it is immersed a piece of iron. The other setup consists of zinc sulfate solution in a test tube, and into it is introduced a magnesium ribbon. And the third setup involved silver nitrate solution, and into it is immersed a copper wire. This is the activity series. This is a list of metals arranged in decreasing order of their reactivity. Okay, most reactive metals are at the top, and the least reactive metals are at the bottom. For any two metals in the series, the metal placed higher in the series can displace lower metals from their salt solution. So, in this reaction involving copper sulfate solution, initially it is darker blue and an iron metal. The result of the reaction is the fading of the blue color and the appearance of a brown product. The copper sulfate color, which is blue, starts to disappear because copper sulfate is consumed here because it is converted to copper metal deposit. While the iron here dissolves because it becomes ferrous sulfate. So from solid iron, it becomes ferrous sulfate, which is soluble. Okay, so what is the driving force here? It's iron and being located higher than copper. So iron is above copper in the series. So iron is able to displace copper in its compound copper sulfate. Nangilog siya position sa copper. So displacement reaction. Iron is able to displace copper because iron is more active than copper because it is located higher than copper in the reactivity series. So this is the balance equation. The next reaction, displacement reaction, involved zinc sulfate, which is a colorless solution, and magnesium ribbon. Okay, so this is our observation, the appearance of a grayish precipitate. So what else do we observe? The magnesium ribbon starts to dissolve because it is consumed in the reaction because it becomes magnesium sulfate. So magnesium is transformed to magnesium sulfate. The solid magnesium ribbon starts to dissolve kasi naging magnesium sulfate na siya, salt, which is a water-soluble salt. And the grayish product here is zinc metal deposit. Okay? So tanawan na to, is it according to the activity series? Magnesium is here and zinc is down below. So magnesium Magnesium is able to displace zinc because it is located higher than zinc in the reactivity series. This is the balance equation. Next is this is a very interesting reaction because you are forming something that looked like a Christmas tree. This is silver deposit. Initially, this is your copper wire. This is immersed in silver nitrate solution. Initially, it is colorless ang silver nitrate. This is the progress of the reaction. Okay, take note, the color of the solution is becoming blue. Okay, nag-darker blue color siya as you proceed from left to right. Nagiging more intense yung blue color ng solution because that is copper becoming copper nitrate. Copper nitrate is soluble in water. So copper here dissolves in the form of copper nitrate, and silver nitrate, the silver here is deposited as metallic silver. So ito yung parang frost dito sa copper wire. Ito yung mga silver metal deposit. Mukha siyang Christmas tree. Okay, so tanawan nato. Uy, na-displace na yung aking. This is copper and silver. Copper nasa ibabaw sa silver. So copper is able to displace silver in this reaction because copper is more reactive than silver. This is the balance equation. This is the solubility rule. Okay, where you have the soluble compounds here and the insoluble compounds. Nitrates, acetates, chloride, bromide, iodide, sulfates are generally soluble at ito namang mga compounds na insoluble. Okay, pero merong exception. Like this one, chloride, generally soluble ang mga chloride, except if they are chlorides of silver, mercurous, and lead. Iodide is generally soluble, pero if they are iodide of silver, mercurous, and lead, insoluble sila. So, exception ito. And sulfate, generally soluble, except if they are sulfates of strontium, barium, mercurous, and lead. Okay. Many chemical reactions take place because of an insoluble product that is formed. Okay. This table is used to determine if you are forming an insoluble product. Okay, dito sa double displacement reaction, we observe formation of precipitates. We carried out 3 double displacement reactions. And the first one involves sulfuric acid and barium chloride. When barium chloride is added to sulfuric acid, which is initially colorless, a colorless solution, magpuputi siya. Okay, so this is now the precipitate of, tanaw na to, kung alin kaya nag-precipitate. Okay, balikan na to ang table. Okay, take note, sulfates. Okay, sulfates are soluble except if they are compounds of barium. Okay, so barium sulfate is the insoluble precipitate in this reaction. Dito naman, the second reaction involves silver nitrate and sodium chloride. Okay, when you added sodium chloride into a solution containing silver nitrate, okay, a white precipitate is formed. This is silver chloride. Balik ta sa solubility table na abay, is this according to the solubility rule? Chloride Chlorides are generally soluble, pero if they are chloride, if they are compounds of silver, exception yan. So silver chloride is the precipitate. Sodium nitrate rather, nitrate is soluble. Kaya this one remains in solution. Kare ang precipitate. Next reaction involves potassium iodide and lead acetate, and there is formation of yellow precipitate. Tanawa na to ang solubility table. Iodide. Okay. Soluble ang iodide except when they are iodide of lead. Kaya ito yung yellow precipitate lead iodide. Ito naman, potassium acetate, asa ito. Is this soluble or insoluble? Dira ang acetate. Walang exception. Okay, so potassium acetate remains in solution. This one is the precipitate.